How can we graph the polynomial function f of x equals x to the fourth minus 2x squared plus 1? First, we identify the sign of the leading coefficient, which is positive, and we also identify the degree of the function, which is 4. Recall that an even degree tells us that the graph has the same behavior at each end. This information and the knowledge that the sign of the leading coefficient is positive tells us that the graph rises to the left and rises to the right. Let's find out the zeros to know if and where the graph intercepts the x-axis. Recall that the y-coordinate of a graph which crosses the x-axis is 0. So let's set x to the fourth minus 2x squared plus 1 equal to 0. We see that x to the fourth is x squared squared, that 1 is 1 squared, and negative 2x squared is negative 2 times x squared times 1. So we can factor x to the fourth minus 2x squared plus 1 to x squared minus 1 in parentheses times x squared minus 1 in parentheses. Now we see that we can factor each of these factors. So we get x minus 1 in parentheses times x plus 1 in parentheses times x minus 1 in parentheses times x plus 1 in parentheses, which we can write as x plus 1 in parentheses squared times x minus 1 in parentheses squared. Now we see that negative 1 and 1 are both repeated zeros with multiplicity 2. Because of the even multiplicity, the graph touches the x-axis at negative 1 and turns around. Let's find out where the graph crosses the y-axis, because this is very simple to find another point of the graph. Recall that the x-coordinate of a graph which crosses the y-axis is 0. So let's plug in 0 for x. F of 0 equals 0 to the fourth minus 2 times 0 squared plus 1. 0 to the fourth equals 0. 0 squared equals 0 times negative 2 equals 0. So what's left over is 1. In other words, the graph crosses the y-axis at 1. In the last video, we learned that the maximum number of turning points of the graph is 1 less than the degree of the polynomial. So the maximum number of turning points is 4 minus 1, which is 3. Recall that a polynomial of degree 4 is symmetric to the y-axis, which is also useful information to graph the function. When we connect these points with a slight curve, we get the graph of this function. We see that 0, 1 is a turning point and 1 is a relative maximum. If the graph would rise above 1 here, it would have to rise above 1 here as well, because of symmetry. But then we would get additional turning points to smoothly curve back to the x-intercept. This graph already has 3 turning points, which is the maximum number of a 4th degree polynomial. Let's recap our strategy we used to graph this function. First, we used the leading coefficient test to know the end behavior of the function. Second, we found the zeros to get the x values, where the graph bounces at the x-axis. Third, we found the y-intercept to know where the graph crosses the y-axis. And fourth, We use the information of the maximum number of turning points and the information that even degree polynomials are symmetric about the y-axis. This video is what I did for you. If you want to do something for me, hit the bell button, like, share and subscribe. Thanks for watching and happy learning, everyone.